So in this video, we are going to create and distribute the houses. We're going to repeat certain number of times of actions for build house. So build house is a function for us to actually building a house. And we use repeat certain number of times to keep doing this. So we will build this amount of houses. And how many houses? We use count patches to count all the patches in the world, in the universe, and multiply the density or the ratio. That means if density is 70, then density divided by 100 means the density ratio is 70%, which means for 100 patches we will be able to build 70 houses. So we use the total patch number multiply the density rate, we get all the houses we could build in the universe. So we repeat this amount of times to build a house. Okay, so we build this number of houses. So how actually we build a house? We need to look at this function, build house. This is a fairly long function. Let's look at it line by line. First, we create houses, just like we create turtles, but we only create one at a time. And when we build this house, we will hide the turtle, meaning we will hide the house. We won't see it, okay? Because we build the house on the patches, so the patch itself is visible to us. That's enough. We don't need to make it more complicated. So we will hide the house. The house is not visible. We only see the patch. And then we will move the house to one of the patches available in the universe. Okay, so we move the house to any one of the patches. And then we will do some conditioning. We will ask, now the house is on a certain patch, but we wonder on this patch, how many houses are there? Maybe more than one house on the patch we are at. Our house is right now placed. So this is the patch our house is on. And we use count houses here. We can count on this patch how many houses are actually on it. Maybe one or maybe two. If on this patch there are more than one house, then this condition will be true. If this condition is true, we will further examine all the patches, looking at every patch. See, on this patch, is there any houses on it? If there is a house on this patch, then this will return true. If there's no house on this patch, this will return false. Now, if it is false, it means no patch or no house on this patch, and the whole thing will be true. If the whole thing be true, then this patch will be saved into this empty site. And we will do this for every single patch. So for every single patch, we will ask this patch, how many houses on this patch? If more than 0, then this is true, and then this is false, and then this is true, then this patch will be saved inside this variable. So after we running all the patches, we may have 0 patch, 1 patch, or more than 1 patch, and we will save the patch into this variable. And this variable is actually an agent set because the number of agents may be more than 1. So it is an agent set or patch set. Okay. So now we know the empty sites are patches without a house on it. And the number inside this variable can be 0, 1, or 2. So let's consider extreme case. That is, what if, well, here, if this is true, the empty site, um, this is a agent set. If this agent set is not empty, any means inside of it there is more than that's one, there's more than 0 agents inside. So any question mark empty site means this is not empty, this one is not empty. So if this is not empty, meaning there is a patch has no house on it. If so, we can actually move our turtle, or which is our house, onto one of the empty patches. Okay? And the reason why we do this is because at the very beginning we did move our house to one of the patches, but we don't know anything about the patch. Maybe, I mean, maybe the patch has more than one house after we moved onto it, and that is not acceptable. One land should not be built with 2 houses. So if that happens, if that land has more than one house, we need to redistribute our house. That's why we redistribute our house onto one of the empty land. Okay, that's the whole condition execution does. So by now we are able to put our house onto an empty land instead of put our house onto an overcrowded land. Now house is being built and the house has been placed in the right place. Now we can try to build the territory for the realtor. Oh, sorry. We have our house. We need to find the appropriate realtors for our house. And the whether it is appropriate or not depends on how far our house is to the realtor. So we will ask all the realtors available, every single realtors, to see the distance between the realtor and our house. And if the distance is within the radius, which means we are within the territory of the realtor. And if that's the case, then we will save the realtor into the local realtors. If there's more than one realtor satisfied this condition, we will save them also into the local realtors. So these local realtors is also an agent set for realtors. Okay, but still, we don't know. We don't know whether there's 0 realtors, 1 realtors, or more than 1 realtors. We don't know. So we have to consider special extreme conditions. The extreme conditions is that we don't have any realtors satisfy this condition. So local realtors agent set is actually empty. So it's false. If it is false, then not false is true. So the condition is met. So we can run this line of code. That means if for our house we cannot find a realtor satisfy this condition, then we will just choose the nearest realtors, regardless whether it is in his territory or not. So the way we does it is we will look at all the realtors, especially look at all the realtors concerning the realtor's distance to our house. And we will compare all those distances and try to find the minimum distance. We will just choose the realtors with the minimum distance. Maybe there are 2 realtors have the same nearest distance to the house, but we will just choose one, just one of them. And we will save that realtor into the local realtor variable, okay? But notice it is plural, so maybe if there are 2 realtors, both of them have the minimum distance to the house, maybe we can save both of them here. Maybe. I'm not quite sure. But either way, we have local realtors. For the extreme cases that we do not have any realtors have the distance to us which is within its radius. In that case, we just choose the nearest one. So now we are sure we will have a realtor for our house. Now we can put the house onto the market. Put it onto the market is actually very easy. We just need to put the house onto the market, which is make it ready to sell. Let's have a look. What does it mean by make it to sell? So let's come back to it. So put it on market means the house property for sale has to be true, ready for sale. So it's true. And the time for the house, the dates for sale is starts from now. So the ticks meaning the time now. So the house is ready for sale and it starts from now. So now we are putting our house on the market. But we can't sell the house forever. It has to have a period of time for the sale. So we start from now. How long can we put it on the market? We make the time, the ticks to be an integer. And the amount of time we will choose is to choose a random number from an exponential distribution. And what kind of exponential distribution? We define the distribution with its mean. And how do we define the mean? Right now we use house mean lifetime multiply ticks per year. So for 1 year maybe just 4 ticks. Now how many years? We use house mean lifetime. This is probably a global variable inside the intervals. So this is given, so this is the mean for the exponential distribution. Okay, let's just have a look at how to use this function. For this exponential distribution, we can have one input or two inputs. If it is one input, it's normally just a mean, like a random exponential give you a mean to define the distribution. If it's gamma distribution, we will need two inputs, alpha and lambda. If it is normal distribution, we also need two inputs, it's mean or standard deviation. If it is Poisson, we need a mean as well. That's how we define, how we use this function.